I have one more video to finish up random variables, I promise, and it won't be a bad one. Okay, so far we've concentrated on finding rules for means and variances of random variables. If a random variable was normally distributed, we can use its mean and standard deviation to compute probabilities. Nice and easy. An important fact about normal random variables is that any sum or difference of independent random variables is also going to be normally distributed. Okay, so we'll take a look at two quick examples and be done with this. Okay, so let's look first at the sums of normal random variables. Okay, so Mr. Starnes likes sugar in his hot tea. From previous experience, he needs between 8.5 and 9 grams of sugar in a cup of tea for the drink to taste right. That is very specific. While making his tea one morning, Mr. Starnes adds 4 randomly selected packets of sugar. Suppose the amount of sugar in these packets follows a normal distribution with mean 2.17 and standard deviation 0.08. What's the probability that Mr. Starnes' tea tastes right? Okay, so the first thing I'm going to say is let x, our random variable, represent the amount of sugar in a packet, in a randomly selected packet. Okay, so we now know that I have 4, right? So I have x1 is going to be packet 1, or the amount in packet 1, x2, the amount in packet 2, and so on. Okay, so we're looking for the combined amount of sugar of those 4 packets. In other words, x1, the amount in x1, the amount of packet 2, the amount of packet 3, the amount of amount of packet 4. Okay, so the random variable t is a sum of 4 independent normal random variables. So that means that t would follow a normal distribution. So the mean of t would come from the mean of each one of these packets combined. Okay, so I'm just doing what I did before. I'm taking they're all normal, so they're all the same, and I'm just going to add them all together because we're looking at the combined for all of them, right? So 2.17 plus 2.17, please they tell you, plus 2.17 plus 2.1123, I have enough. Okay, so the mean of our 4 packets combined is going to be 8.68 grams. Okay, so I'm going to need that number. Okay, now let's talk about my standard deviation. Okay, so I definitely need my standard deviation. I'm going to use my normal distribution to find the probability here. So I have to have my standard deviation. That's going to be found by your variances. So my variance for each one of them is going to be 0.08. And I have to square that because that's the standard deviation. And I have 4 of them. So obviously I could do 4 times this, but I am taking the long road. Okay? And so then that's going to give me a variance of 0.0256, which will then give me a standard deviation of about 0.16 grams. Okay, so I need this, and I need this to be able to calculate my probability. Okay, so I am looking for the probability that his tea tastes just right. So they address it in the first one that it needs to be between, or the first sentence rather, that it needs to be between 8.5 and 9 grams of sugar. Okay, so in other words, I am looking for the probability. I'm going to work right here. Okay, that the sugar is between 8.5 and 9 grams. Okay, so that's where we start to use our calculator. So I'm going to norm CDF, my lower bound, my upper bound, my mean of the 4 combined packets, and my standard deviation of my combined 4 packets, which was 0.16. Okay, all of this is going to give me an answer of, or a probability of, 0.848. So that's about 85%. Okay, so what we can say is there's about an 85% chance that Mr. Starnes' tea will taste right. Okay, so let's look at one more quick problem. Okay, so the diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with mean 3.96 inches and standard deviation 0.01 inches. The diameter L of a randomly selected large lid at this restaurant follows a normal distribution with mean 3.98 inches and standard deviation 0.02 inches. For a lid to fit on a cup, the value of L has got to be bigger than the value of C, right? So that's going to tell us I need to do this, okay? So the mean is going to be the easy one. We know all I have to do is subtract them, okay? So the larger cup was 3.98 minus the C was, or is it 3.96? Okay, so that means that the difference, the mean of the difference is 0.02. Okay, the variance is again going to, or the standard deviation is again going to be coming from the variances. Now, just because, again, I am subtracting doesn't mean that I subtract here. So I do have to add still the variances. So despite that, you're looking for a difference. It's the sum of the variances. Okay, so I have 0.02 squared plus 0.01 squared, which gives me 0.005. That is how I'm going to find my standard deviation. So it's about 0.0224. Okay. Now they go on to tell you that you are looking for a lid to fit on a cup, the value of L, but not more than has to be bigger than the value of C, but not more than 0.06, right? So you're looking for the probability from 0 to, well, it's not X. We used D to 0.06. So this is where we know it's a normal distribution, so we're going to use norm CDF, lower, upper. Mean is the difference of the two diameter means, and standard deviation. Okay, and I'm going to rely again on technology, and that is going to give me about 0.777, so we'll say about 78% chance that a randomly selected large lid will fit on a randomly chosen large drink cup at a fast food restaurant. And that is it for random variables, sort of.